Hi, my name is Millie Robinson. I'm a graduate of the Energy Transition Engineering course at the University of Canterbury, and I'm now an intern at Transition HQ. I'm working on a transition project in Masterton, but because that's still a work in progress, I'm going to give a report on a shift project that was undertaken some years ago and has already been successful. So, wind air pollution from wood smoke and cars at a level of above 50 micrograms per cubic metre of air triggers an increase in hospital admissions for respiratory and cardiopulmonary crisis. The harm being done by wood heating has been well known for hundreds of years. So, some statistics for this. In 2016, air pollution from human made particle matter of 10 was associated with an estimated 1,277 premature deaths, as well as 236 cardiac hospitalizations, 440 respiratory hospitalizations, and on top of that, 1.49 million restricted activity days. So that's across the whole of New Zealand, and you can correlate that to what's happening in Christchurch. So in 2001, Professor Crumdyke and a master's student did a transition engineering project for the wicked problem of home heating and health in the city of Christchurch. So they first looked back at the history, as you do, and they found that the struggle with air pollution for heating in Christchurch was as old as the city itself. 100 years ago, the air pollution was actually much worse than today because people were using open fires to burn wood inefficiently, and they were also burning coal. The solution for sustainable, renewable residential heating is clearly waste wood. Virgin wood actually has a low EROI if it is far away from the end user. So you're better to use wood that's already in the region. Using wood biomass to generate electricity has an EROI that's quite low as well. So it would require more waste wood, therefore it's less viable, not viable. Okay, so it didn't take too much of an analysis to identify wood pellet fires using waste wood from the region, from the local sawmills, as the obvious solution. If you have a small, well-insulated home, then a heat pump could handle the heating load, but the winter peak coefficient of performance is actually very low, and it also adds to the critical peak, the electrical critical peak. So pellet fires use 60 to 200 watts of electricity, depending on the function chosen, the fan speeds, which give you the heat output. So they're much lower. So the insight was to work with Solid Energy, the national coal company, to transition from a supplier of coal for domestic heating to a supplier of wood pellets for domestic heating. So the shift project here is therefore a business opportunity that involves some key parts. First, to talk to the Christchurch City Council and to change the Environment Canterbury ban on burning all solid wood, which mistakenly included banning wood pellets and fires, which perform very differently, don't need to be banned, but actually encouraged. And the final year mechanical engineering project was to install pellet fires in 12 University of Canterbury owned homes. These homes are from a range of eras, including the 1920s, the 1950s, and so on. And the student project would test the performance and the cost of running the pellet fires in these different styles of homes. Another final year mechanical engineering project was to develop a business plan for uptake, which included the transition of Solid Energy, the coal company. So Solid Energy would capitalise, invest money in Nature's Flame pellet factory, and it would also end the sale of coal for residential use in Christchurch. So remembering that this is a shift project that was studied in 2001 and then undertaken some years ago now, we can see its success. We can see the number of days that particle matter 10 exceeded the World Health Organization since then. We can look at Christchurch as a city and we can see that there are 9 pellet fire stores in Christchurch when there used to be just one guy. You can also purchase pellet fires from Mitre 10. The supply of pellets is secure. In fact, New Zealand is exporting wood pellets to the overseas market. You can get a wide range of styles to suit your style of pellet fires, including the wetback pellet boilers that you can use to heat your room by circulating hot water through the radiators. You can use the wetback to heat your water cylinder, or you can do both. The cost of a pellet fire, illustrated here, can be lower than a heat pump, or you can splash out and get a very flash model for your fancy house up in the Kashmir Hills. Essentially, sustainable, renewable, clean heat is now a reality, just very normal in Christchurch. There's also new council rules which impose fines on smoking chimneys, so the shift to pellet fires is continuing pace. Okay, so a successful shift project in Christchurch can now be used as an example for shift projects in other towns around New Zealand. There are numerous towns that exceed our air pollution standards. We also have the big project of reducing winter peak demand. So in conclusion, it's clear that pellet heating with wood pellets made from plentiful waste wood directly downshifts the gas power generation to meet winter residential heating loads. A 25% penetration of wood pellets to replace or augment electric heating could reduce winter peak by 350 megawatts. So now we have, now the shift project is to go from electric resistance heating and to augment heat pumps if they're used in uninsulated homes, and to replace log fires in towns that suffer from air pollution. This is part of the transition project that I'll be undertaking over summer based in Masterton. Cool, kia ora, thank you.